This is a quick video over copolymerization, and all I want to do is show you how to derive this equation. So this is a insanely simple video. I'm not going to go into great depth. I'm just going to show you my math. So let's get started. So here are our basic kinetics equations, basic reaction equations. And with that, we can find the consumption of monomer 1 and the consumption of monomer 2. This equation is right there. So that's just the basics right there, and that is right here. And then this one comes from right there, and this one comes from right there. Sorry for not going into too great a detail. I just want to show you the overarching steps to get through this. And these are very basic stuff. So, all we want to do is just divide these two equations by each other, and that will get rid of the dt's. So then we just have this equation where we have the change in monomer 1 with respect to the change in monomer 2. Now, one of the bigger steps is if we assume the interconversion of the two radicals are about the same. So what we're going to do is we're going to assume steady state. So if we assume steady state, then what we can do is we can solve for the monomer 1 radical concentration at the end of the polymer. So therefore, we can get this equation. And with this equation, we can plug it in right there, and we can also plug it in right there. So with that, we get this new equation down here, this little colorful guy. I tried to make it as colorful as possible. Now, that has monomer 2 radical, monomer 2 radical, monomer 2 radical, monomer 2 radical. So those all cancel out. And then it simplifies to this. Actually, this cancels out there, and that cancels out there. Those are the same. And then we continue on. If we define R1 as K11 divided by K12 and R2 as K22 over K21, then we can then put K1 over K2, so that just becomes this, and this just becomes R1. And K21, well, that's right here, and right here. So if we just divide everything by K12, K21, then that really just cancels out all right there. So then we have this, and we can say this is now R2. And then monomer 1, multiply that all through, and we get this thing right here. Now, the next big thing is if we say F1, little f1 is equal to monomer 1 over monomer 1 plus monomer 2, and then F2 is equal to monomer 2 over monomer 1 plus monomer 2, well, what do you notice? These both have the same denominator. So then really, since this is already a division problem, we can just plug this right there and this right there, and this part will cancel out with that part. So really all we're doing right here is we're just putting wherever there is a monomer 1, we're putting F1. So I kind of broke it up into a step right here. So basically all I did was if you saw monomer 1 here, you put F1. If you saw monomer 2 there, you put F2. So that's how we get this equation. And then you can further simplify it right here. So then you get this simplified equation for this. So that is what that is equal to. Now for the, I believe it is the mole fraction of monomer 1 in the copolymer. That is equal to the change in monomer 1 with respect to the change in monomer 1 plus the change in monomer 2. And this actually just simplifies down to this. So then what we can do is we can plug that to right there, and when we do that, we get this equation. So now that we have this equation, we can just simplify it by moving this right there and this right there. And then if we further simplify it, we notice that this and this are the same, so that just becomes 2F1, F2. So then finally, we're at our bottom equation, our main equation that we're looking for. And that is how we get it.